Let's call then Dr. Oleksii Goodson. He is graduated in physics of materials. He was graduated in 1994, has a master in nuclear engineering by the University of São Paulo in 1998, and he is also a doctor in physics by João Vieira in 2003. He has experience in the areas of physics with emphasis of equation of states, balance, and phase transitions. He will be talking about the focus of the National Institute of Metrology in issues pertaining to nanotechnologies. You've got 15 minutes, so good luck. Good morning, ladies and gentlemen. I'm in a very difficult situation because I only have 15 minutes. This like over an hour. And after the this speech, I'll probably have a few answers for you. So I'll keep on talking when if the coordinator so decides, they can interrupt me. In this presentation, I want to talk about the main activities of Inmetro. In terms of the issues of nanotechnologies, basic issues that are necessary for the construction of a regulation scheme, as we are thinking here. Obviously, I do not have a lot of time. However, I will just point to you the main areas of Inmetro, such as education and metrology, and I will show you the tools that we have. We do have tools to assess products and also to verify the quality of such products, and also to make sure that the people who evaluate these products are well trained. There are some doubts of ethical issues when we discuss with nanotechnology. So independent of your opinions, one thing is absolutely right. We will have to live with, from now on, with our capacity, sometimes awesome capacity of manipulating matter. Certainly, the most intelligent way to adapt to this new reality is to face this reality, to adapt to it, as it was well explained by Francisco de Espírito Santo Neto in his book, From the Universal Parables of a Famous Poet from France, 17th century, La Fontaine. So it depends of us how we're going to adapt, how we're going to control this technology, and we're going to quickly detect its inherent risks, and we can protect ourselves from such dangers. Or we're just going to be observers being taken by the wind or with these new discoveries. I'm pretty sure that we are all here to choose the first option. Now, I just want to discuss two basic points that would define the need for regulation in nanotechnology. To explore nanomaterials has to do with our relationship with the nano objects, with this object that are nanostructured. The positive points for this, because normally what we're looking for is it's a system that's atomically perfect, that will be able to deliver not the known qualities for the physical materials, but besides the positive application of some materials, we do have surprises with the interaction of these materials with biological materials. We have seen examples that harmless materials can be very dangerous when they are at the nanoscale. But there are also toxic materials. They lose their capacity of causing harm when they are at the nanoscale. In a general way, without meticulous experimental studies, we are not going to be able to declare if a material is dangerous or not. The second fact I want to call your attention to is the growing volume of manufacturing of such materials. Practically all of the systems of materials are involved in all sectors of the industrial activities. So I numbered here 1 to 6 what we have. And problems of health and environmental are proportional to the volume of production of this material. So this is very important, the uncertainty in terms of its properties and a growing volume of products of such materials. So the regulation becomes extremely important when you consider such facts. And the role of institutions such as Inmetro, it's essential, this subject, because the nature of its function, we give trust when we regulate products. And through the activities that we have for the sustainability of the credibility of Inmetro as a reference laboratory of metrological activities. Our main objective of these activities are to make sure that Brazil will remain competitive in its economy, open new spaces, new markets for this economy. And without a doubt, the main priority of Inmetro are issues pertaining to health, safety, and environment. Several essential items have to be resolved, and many of these items are in the agenda of metrology and the objectives of Inmetro, besides instrumentation and tuning of this equipment, the development of reference materials, which are basically the confirmation about the properties of such materials. Technological processes, measurement, correspond to the demands of rules that are being detailed in other documents. If we want to advance, if you want to achieve something with this technology, we do have to resolve these main issues, as it was done by the famous Irish physicist Lord Kelvin, William Thomson. He said, if you want to assess anything, measure it. If you cannot measure it, forget it. And I also would like to go over with the focus of Inmetro nanotechnology, and I'm going to tell you some of the challenges that we have, that the Inmetro has to face. And in a certain way, it does affect broadly the daily life of Brazilians. Without a doubt, I would say that education, the education of specialists in nanotechnology, it is the necessary ground to support all of the activities in this area. Now in Brazil we have a chronic lack of specialized labor, which is bringing us an immense loss in several areas. So I want to show you the creation of a core of higher learning in Inmetro, in Inmetro facilities. And we're doing that with our partners. It's very important. You can see here the courses that we have. the methodology course started this year. We have around 60 students already there for this course. It's very important that students, since the second year, they are able to go in the laboratory. They know good measuring practices and also methods for analysis. It's the only way we can achieve our objective. Many other objectives and activities are being developed, and one of them is the construction of a technological park for Inmetro, which are telecenters of distance learning for the training of the Brazilian network of legal metrology. So basically, these are classrooms that use modern communication means with the internet, the last generation of equipment we use there. So we have 36 telecenters that are already operational. They are spread all over Brazil. They developed this project that's in beginning now. Our technological change, this fast technological change, need also fast answers. So obviously, this infrastructure is for this end. The fact that we have developed scientific metrology being developed at the nanometric scale, I would place this as a foundation that building education, the land, the metrology is the foundation of this building that we can call nanotechnology. The federal government has invested heavily within Inmetro the last 3 years. And besides the development of classic metrological areas like thermical, optic, mechanical, and tuning, we also created new areas to address the new technological needs. Chemistry, biology. Yesterday we had a detailed presentation of this area, very interesting. The base of this division of metrology of materials, with the partnership with the Ministry of Science and Technology, we created a center of nanotechnology that has a very strong laboratory and instrumental infrastructure, and its main focus are to develop analysis techniques besides research for materials, nanomaterials, and also to help the demands of society or the government. The key problem today, the primary problem we must resolve in nanotechnology, it's the standardization, or in other words, to transfer the primary measurements for the instruments that they measure the properties of nanomaterials. There are several strategies on how to do that. One of them is like this, but I really do not have time to do that. But both in this area of standardization of primary measurements, but also terminology and definitions. So Inmetro has the task, because it participates in the ISO TC 229 that deals with the standardization of the study, the control and the use of these nanomaterials. Another very important initiative that we have several work groups in this project. What's the VAMAS, the Advanced Materials and Standards, a project that was started at G7 of some time ago, just such, and also with Brazil, Inmetro is beginning with a number of these projects. It's a harmonization of measures, essays, specification of these nanomaterials. Besides a routine participation of Inmetro, a systematized participation, which are coordinated by the International Bureau of Measurements and Weights that maintain all of the international reference for those standards. Now let me change the subject a little bit. And one aspect that's extremely important for the construction of a metrological control in the industry is a specific orientation for the industrial metrology that needs a least costly, efficient, and fast analysis methods. I have time to read this. I don't have time to read this table, but because it's self-explained. So I'm gonna just go very fast and just show you a few things like the diffraction of X-rays. Besides the analysis of phases that will reveal the structure, we can extract the dimensional information about the objects. Again, it's indirectly using certain models and theories so that we can get to the results that you're seeing here. So we have the Raman Spectroscopy. Perhaps it's the one that has the most probably use or application and use. It's already used because from the electronic properties of materials, we can extract, again, information about dimensional analysis, so like carbonaceous materials, like graphite and carbon itself. Many other techniques are being dominated by the industry. They can be used with precision for normative effects to establish protocols to guarantee the reproducibility of certain experiments. That's the most important thing, you know. That's where we are now. But we have to go very fast. Now, what's most important here? Legal metrology. It is a tool used by the state to establish procedures, legislative, administrative, technical initiatives to guarantee a certain level of quality in the procedures of the instruments that could, in some way, could offer some risk. These tools, they exist today. So Inmetro is the executor of that has its attribution that have been detailed in the law to execute that's required for all the players, and in fact Inmetro. So we have over 40 measurements. We have many things: thermometers, equipment to measure pressure and heartbeats. And once we have the risks of nanotechnology, they will be defined by nanotechnology parameters. So this regulation is very important. It's important that the guarantee of classification of such risks, that we have quantified these risks, this is important as tools for legal metrology. So the general structure of the legal metrology in Brazil is well consolidated, and if follow the political guidelines from the committee that's align these metrological initiatives with the International Organization for Legal Metrology, its recommendations. And now we have a network that covers the entire Brazilian territory with a strong structure in the states. And finally, I want to show you two slides very fast. So because we do not have a control of this, of the system. We have tools to control, to guarantee the quality of the production. So that's conformity of assessment programs or tools. And its main objective is to give trust to the markets, to guarantee for the consumer that the quality of that product abides all regulations. So the main certification we're using here is the diversity of such necessities. That is one of the factors of nanotechnology, a diversity of mechanisms to assess the quality of such products. So we will soon work on our plan for the next 4 years. So perhaps it's important to create a pilot program to evaluate some of these products. So we have 120 programs. We have criteria for priorities. That's where we have the health and environment, and then of course financial considerations. And finally, is to talk to you about the accreditation. Again, it's a tool that Inmetro uses to certify the ability, whatever algorithm you use to classify, we must make sure that that result is correct. It's very difficult, specifically when you consider the dimensions were involved here. Not only laboratories, but the organisms that do the certification and inspection. I believe that accreditation will have its greatest role. He's in international acknowledgement of results important, so we don't use this technological barrier. I'm pretty sure that the accredited laboratories that have proved that they are able to produce, they will be highly requested in the future because they will be definitely needed. So without a doubt, we are at the beginning of a long path that we have to follow. So it's important from the beginning to formulate a strategy that will guarantee, will give direction nanotechnology in Brazil, to put it in the right way, a pathway that will have sustainable economy, safe, highly competitive, and focused in the society's needs. I would say that that's an absolute condition to any development in nanotechnology, the existence of metrology, advanced metrology in this area. I said many times, I will repeat, it's not exclusively to Inmetro to address all the metrological needs that Brazil may have. We have to be realistic here. So it's very important to have the involvement of all of you in this metrological effort. And to finalize, again, I want to go back to Francisco de Espírito Santo Neto. He says that before the new, we don't always need to change the path. Sometimes we just have to change the way we walk. So we have to adapt to these new realities, and this is the page here for my to thank all of the people who have helped me. So I also want to thank you for your attention.